Okay, algebra, we are in section 3.3, and today we're going to solve some multi-step equations, so things get more fun and more interesting. Let's try this first equation. Leave a little space because there's a strategy we're going to use, and I want you to think about what that strategy might be first here. So, in this example A, what will we do first in order to solve for x? So give it a try. And, okay, good. So the first thing I want to know is this x is sitting all by itself. What is the coefficient for x? And the coefficient is 1. Right? So good. So we really have 9x plus 1x. And so what is 9x plus 1x? 10x. All right. So that first step is something you're going to see a lot today, and we call that combining what? Like terms. Okay, so we're going to combine like terms, and then we're right back where we were yesterday in a two-step equation. So we'll undo operations in reverse PEMDAS order. So the next operation to undo is at minus 7, add 7 to both sides, 10x equals 20, and the final inverse operation is division, right? The division property of equality. And we have 1x equals 2. Don't forget, we can plug it in, right? We can plug it into both places, right? 9 times 2 is 18, and plus 2 is 20. 20 minus 7 is 13. In example B, there's something a little bit different going on. So look at this. It's a little more complex. What will we do first? Pause the video, give it a try, and come on back. Okay, so we see this parentheses, and what is inside of the parentheses is x minus 2. Those are unlike terms, so we cannot combine x minus 2. So we see a negative 7 outside the parentheses, right? Let's change that so it's really clear. This is a negative 7 plus a negative 7. Right? We could also change what is inside the parentheses to plus a negative 2. So our first step will be to distribute. Multiplication comes before this addition, right? So bring down the 4x plus negative 7 times x plus negative 7 times negative 2, positive 14. All right, now we are in a position to combine like terms, right? 4x plus negative 7x is negative 3x. Okay, and now we're at a two-step problem again. So our next operation will be subtraction property of equality, right? Subtract your 14, negative 3x equals 12. And the division property of equality, divide both sides by the same term, and we have x equals negative 4. Very good. Once again, we can check that answer by substituting it back into the original, right? Negative 4 times 4 is negative 16. You know, it's kind of hard to see the original. Let me pull it over here. So negative 4 times 4 is negative 16. Negative 4 minus 2 is negative 2, right? And so this is a little tricky. Let me draw it out here. We have negative 16 minus 7 times negative 4 minus 2 is negative 6, right? Equals 26. Is this a true statement? Let's see. Negative 16. Let's change this to adding an opposite, right? Negative 7 times negative 6 is a positive 42 equals 26. And now we have opposites here, negative 16 and 42. Let's subtract the 16, and we get, 26. Good job. 26 equals 26. So when we substitute our solution into the original equation, we can prove to ourselves that we have the correct solution. So this is called, let's back it up. Oops, I dragged the whole thing over. This is called using the distributive property. All right, we use the distributive property, and then we combine like terms. All right, I'd like you to try 3 other guided examples, and then you're on your way today. So pause the video, give this a try, and come on back. All right, I hope you're changing your subtraction to adding the opposite. 9d plus a negative 2d is 7d. And of course we use our subtraction property of equality. 7d now equals 28, right? And we divide by 7. d equals 4. Did you check that out in the original equation? Let's see, if d equals 4, 9 times 4, 36, minus 8 would be 28, plus 4, yes, it's 32. Number 2, pause the video, give it a try. Come on back. Once again here we're using which property? The distributive. All right, so let's bring down 2w plus 3w plus 3 times 4 is 12. All right, and now what will we do? Combine like terms. 5w plus 12 equals 27. And then I'm sure you subtracted 12. And 5w equals 15. And we can see we need to divide by 5. So w equals 3. Let's check this out in the original. 2 times 3, 6, plus 3 plus 4, 7. 3 times 7, 21. 6 plus 21 is 27. And the final example today, look at that. It's a little trickier due to the negatives, so be sure you're careful with those. Come on back. All right, let's change this to adding the opposite. Adding the opposite. Once again, we see we've got to distribute first, right? So bring down the 6x, and negative 2 times x is negative 2x. And negative 2 times negative 5 is positive 10. Okay, we're ready to combine like terms, right? 6x plus negative 2x. And two-step problem. Subtract 10. And what will we do? Divide by 4. X equals 9. And did you check it back in the original? Let me pull the original out. Whoa. Let's see if I can get it to come together here. Good. Okay, let's plug our 9 in here first. 9 minus 5 is 4, right? 2 times 4 is 8. Okay, so there's an 8 over here. 6 times 9 is 54. 54 minus 8, yes, that's 46. Okay, so be sure to check your answer. Give yourself a star, and you're on your way. Be very careful to check your work today. Okay, so this is day 2 for 3.3. I'm going to include it on the video for this section, solving multi-step equations. Yesterday, you were using the distributive property and combining like terms. So today it gets a little more complicated on day 2. We see fractions. They always make our life more complicated, right? So what is a single step that could be used to remove this fraction from this entire equation? And I bet you're saying multiply by the reciprocal. If we multiply by the reciprocal right now, we won't distribute a fraction across this expression, which would leave us with a lot of tricky fractions. So remember, when we multiply reciprocals, we get 1, right? So 1 times 2x minus 4 leaves us with simply 2x minus 4 equals 3 goes into 18 6 times, right? So 6 times 5 is 30. Now we're back to a basic two-step problem. Very nice. So next step, add 4. And we have 2x equals 34. And when we finish by dividing, we have x equals 17, right? All right. So again, we can check this in the original. And 17 would go in here, right? Look at the blue equation. So 2 times 17 is 34 minus 4 is 30. 30 times 3/5, well, 5 goes into 36 times, right? So 3 times 6 is 18. So you can go work that out, substituting 17, and find that it is true. So this strategy is called multiplying by the reciprocal to solve. When we multiplied both sides by the reciprocal, we ended up simplifying this complicated equation into just a simple two-step equation. All right? So go ahead and try that yourself, and then we'll walk through it. So hopefully you multiplied both sides by the reciprocal. Remember to flip it, right? Let's see, times 4/3, and this gives us 1, right? 1 times z minus 6 is simply z minus 6. 3 goes into 12 4 times. 4 times 4 is 16, right? And so to finish, we add 6 to both sides, and you should have z equals 22. All right? And that checks out. So number 2, pause and come back. All right, multiply again by the reciprocal. Multiply by 5/2. We have 1 times 3r plus 4 equals, 2 goes into the 10 5 times. So 5 times 5 is 25, right? Now we're at that basic two-step problem. Subtract 4 from both sides. 3r equals 21. And when you divide, r equals 7. All right? If we plug 7 in for r up here, 21 plus 4 is 25. We would have 2/5 times 25. And does that equal 10? Let's see. 5 goes into 25 5 times, and 2 times 5 is 10. Give yourself a star. All right, so this is the final example for you to try. What makes this one more challenging? Do you see it? Yeah, negatives. We have a negative factor and we're subtracting 1. So make sure you pause the video, give it your best try, come back and check. The first step, I think I'll change the subtraction to adding the opposite so we can keep track of our negatives, right? And once again, rather than distributing this nasty little fraction, we will multiply both sides by the reciprocal. All right? So multiplying by negative 5/4. Notice I keep the negative in the numerator. Most people do, so that we can keep track of what the entire value is, and that value is negative, right? These are multiplicative inverses, so that equals 1, right? We're left with 4a plus negative 1 equals, let's see, 4 goes into 28 7 times, and 7 times negative 5 is negative 35. What is the inverse of adding negative 1? Subtracting negative 1. Isn't that funny? Say it that way. Subtracting negative 1 is simply adding 1, isn't it? Plus 1 to both sides. Negative 1 and positive 1 would leave us with 0, right? And negative 35 plus 1 is negative 34. When we divide by 4, we end up with a not going into this, 4 does not go into negative 34 evenly, does it? So it goes in, 4 goes into 34 8 times, right? Negative 8, that would be 32. And what would the remainder be? 2. So 2/4, which is 1/2. Negative 8 and 1/2. If we plug in negative 8.5 for a, let's go back and use this, the improper fraction we had here. Negative 34/4 times 4 is simply negative 34, right? Let me bring that up. And negative 34 minus 1 would be negative 35. Negative 35 times negative 4/5 leaves us with, guess what, 28. So you have done a great job, and be very careful to check your work in your assignment today.